Hello, I'm Richard with EV4U Custom Conversions, and welcome to another episode of the EV Answer Man. In today's episode, we're going to talk about the JLD404 Intelligent AH Meter. For lithium-ion conversions, which is the standard today, this is a gauge that's really handy to have. It provides all the information that you will need to monitor your lithium pack. In lead acid days, you could use a voltmeter for your state of charge. Today, that doesn't work with lithium. We need to keep track of the energy that is going in and out of the pack. And so that's where the JLD404 is handy. Basics that we need to monitor for our pack. So what we're going to do today is we're going to talk about the features. We're going to talk about wiring of the meter and programming and operation of the meter. Well, first let's take a close-up look at the meter, what we're talking about. Here it is. It's not very large and has 20 connections on the back. It's rectangular, easy to make a hole for it to fit. Let's talk about the features. Well, let me skip ahead real quick while I've got this in my hand. This is the JLD404. What you need with that is a shunt, and this is a sample of a shunt that we use, and this is a 500 amp shunt, 50 millivolt, and as we've discussed in other episodes, a shunt is just basically a known resistance, and so what that meter is actually doing is it's measuring the voltage drop across this resistance. We offer the two, and you can get different shunts for different systems. This is just a 500 amp that I'm showing you. And we offer the shunt and the JLD404 for $149.50. So if you're interested in purchasing that, you can email us. I don't think we have it on the website listed as with the rest of the parts that we offer. You request something, we can get it to you. Anyway, back to the features. What this does is it basically displays 4 functions, only 3 of which we're really interested in as far as the display goes. It will display volts. And so what we're doing is we're monitoring the pack voltage. It monitors amps. That's what we're using the shunt for then. The amps in normal use, how I use this instrument is that's the display that I have normally selected, is the amp setting. And I use that as an efficiency gauge. And then amp hours. And that's the most important aspect of this JLD404, or one of them, is the amp hours. And so it has a built-in clock. That's the 4th function. But it's not a 24-hour clock. It's just a running clock. So after you reset this thing, it just starts from 0 and counts the seconds. And so it has to do that in order to calculate amp hours. So it's measuring the amps versus time, and that's how it gives you the amp hours. Also on the front, you will notice that there is a plus and a minus, as well as a J1 and J2. The plus and minus just is showing you current flow. J1 and J2 are internal relays. They're single pole double throw relays, so they have a common, normally open and normally closed contacts. What's really nice about these relays is that you can set the thresholds. You can set an upper and lower value. And we'll go through that in the operation part of this. So that's nice features that you can, at a glance, you can see what the voltage is. You can see what the current flow is in this, and you can see if it's going in or out of the pack, which you would probably know, but you know, with regen and so forth, it's nice. So you can see whether it's which direction the current flow is, and then of course these onboard relays. What we typically use these relays for are, we'll use J1 to shut off our charger. And so even though our charger is programmed to match the battery pack, and so if we were charging, in the case of the Karmann Ghia, 3.5 volts per cell, there's 44 cells, 154 volts, the charger is programmed to shut off at that point. But as a redundancy, we also have J1 set up so that it will shut the charger off at that point also. So we have that kind of fail-safe built in. And then we use J2 as a low voltage fail-safe. Most of your controllers can be programmed for a low voltage, you know, to go into a limp mode or shut down. And we can do the same thing using J2. Again, it's a redundancy to protect the most valuable portion of our conversion, and that's that battery pack. All right, we're going to talk a little bit about some of the operation features before we get into the wiring, and then we'll go back into the operation. And most of the operation stuff, the program, everything will be done in the vehicle. But I just wanted to go over a few of the basics here. On the front of the panel here, you'll see that it has a set side arrow, up and down arrows. Now, you press the set button to enter the menu. And then there's what I call the main menu, which I'll show you how to get into that, but there's a code for getting into the main menu. It's 0036. And then there's a separate menu for setting the parameters on our two relays. And so again, from the set button, we enter 000001, and that will put us into the relay menu. Now, if you want the display to scan between your amps, your volts, your amp hours, and the timer, you just press and hold the side arrow, and it will go into the scan mode. And then, kind of the big picture, typically how we use this is when you charge your battery pack and the charger's shut down and you come back to your car, you're going to use it, you unplug it, and I will look at my voltage to confirm that the voltage is what it should be. And that's what the volts is nice for. If I were to have a bad cell or something, or one that's a little bit low, you know, that's where it's going to show up, is looking at my pack voltage. And then I will circle through and look at the amp hours, and it may not be exactly at 0. There's a slight discrepancy based on the rate of charge and the rate of discharge being different that can cause this thing not to go exactly back to 0. There's also, you know, the temperature of the shunt and everything will affect its accuracy. There's a lot of variables. So we want to have the ability to reset it. And so you press and hold either the up or down arrow, and that will reset the timer to 0, and it resets your amp hours to 0. Now, personally, what I do is I have it set up so that when power is being drawn out of my pack, when I'm using energy out of the pack, the negative light will come on and the amp hours are counting up. And so if you have a pack like what's in the Carmen Gia, again, it's a 100 amp hour pack. I know that 80% of that's usable, so I have 80 amp hours usable. And so I'm watching that count up. And when I'm at 40, I know I have half of my capacity remaining, and so forth. At 20, you know, you're a fourth of it. At 60, I got a quarter of it left, so forth. And when I plug it in and it's being charged, it's the plus indicator comes on. Now I'm putting power back into my pack, and that amp hours used is getting smaller. Now you could wire it up, just simply wire the shunt wires in reverse from what I'm going to show you, and it would count the other way, and so in a negative way. So it's up to your own personal preference. But anyway, those are kind of the main front buttons and controls. So now let's take a look at how we wire this up in the vehicle. All right, so what I've done is this is the back side of the JLD404, showing the terminals, little terminal screws, where you would connect your wiring. So they're numbered 1 through 20. And so number 1 is our positive 12 volts. This is unswitched. In other words, this needs to be powered all the time, so that when you're charging, it's keeping track of it without having the ignition on or so forth. That's unswitched. I would recommend a fuse in line with there, which isn't drawn in the drawing here. And then number 2 is our 12 volt ground. Number 5, well, we'll talk about 5 and 6. If you were doing a project that was a 96 volt or a 72 volt project, this would be the terminal you would use. 100 volts and less, you would use, of your pack voltage, you would use number 6. For pack voltages over 100 volts, you'll use terminal 5. And so in our example today, it's 146 volt nominal, 154 volt max. And so we're coming off of terminal 5, and that goes to the most positive point in our pack. So that is pack positive, traction pack positive, goes to terminal 5. Then 9 and 10 are our shunt connections. And so we're going to show you how to program that in a bit, but this is a 50 millivolt. We're going to connect it to the 75 millivolt connection here, but they have others here available depending on shunts that can be used. Most of the shunts most people are using are a 50, 75 milliamp, or millivolt, I'm sorry. And so the negative for the reading on the voltage, this is a question I've had before. Somebody's like, hey, I'm not getting the volts to read. Well, they didn't have the shunt located in the most negative point on their pack. And that's very important. The shunt must be the most negative point in your circuit, so that whether you're charging or discharging, whatever loads you may have, DC to DC converter, everything has to be on the opposite side of the shunt from the pack. It has to be the negative-most thing. And so the voltmeter part of that is getting its negative reading off of the shunt. And it's getting its positive over here, like I mentioned a moment ago. So anyway, negative most point in the circuit. And then for your meter to operate the way that I was describing, you want, there's two screws. Let me grab the shunt again. Sure, you're all familiar with the shunt. Well, here's where your high voltage leads come in and out. And these two little screws here, those are what go to the meter. The side that is going to be connected to the negative side of your pack, this one needs to go to common. And this one will go to the 75 millivolt connection. It's no big deal if you reverse them. If you reverse them, your meter will just read in reverse. That's it. Not a big deal. So if you do hook it up incorrectly, just swap them and you'll have it the way that you want it. Okay. So that's providing power for the JLD404, our 1 and 2. That's our 12 volts. Nice feature about the JLD404 is that if you're using it and you have a certain state of charge and you do work on the vehicle for some reason, you disconnect your auxiliary battery, when you connect it up again, it will have the same amp hour reading that it had when you disconnected power. It doesn't lose that. And so that's a nice little feature. And then of course these are the shunt connections. Now 15, 16, and 17 are J2, 18, 19, and 20 are J1. And so the connections at 19 and 16 are the commons for each of those relays. And then, so 19 and 20, that's your normally open. 18 to 19, that's your normally closed on J1. 15 to 16, that's your normally closed on J2. 16 to 17 is your normally open on J2. So, very simple to wire up. And like I said, we'll go into some greater detail on some of this, specifically J1 and J2, in the operation part of our discussion. So let me show you the menu overview, and then we'll go look at it in the vehicle. All right, like I said, in what I call the main menu, where we're going to hit the set button and hold it until you get the 4 zeros show up, and we're going to enter 0036, and that'll take us to this main menu. And you can scroll through that menu, and again, we'll do it on camera in a moment. And these are displays that will be displayed. A-SN, that's the current input value. You're going to have APUL, that's a zero offset amps display. But basically, any of these, the A is all going to be current settings, and the U are going to be voltage settings. So you can see we have our zero offset for amps, full scale value for amps, the decimal position for amps, and then when we go to the USN, it's voltage input, the zero offset for volts, full scale value for volts, decimal position, so forth. Then the last thing it'll show, or next to last thing it'll show, is filter. And that's a filter value. I recommend just leaving it on 0. I think it goes 1 to 4. We'll take a look at it when we bring it up. But basically, I don't know anybody that has used that for any reason, unless you had some kind of other line issues and had noise and needed to filter it out. Never been an issue, so we just set it on 0. And then end, when you select end, it just exits the menu. So that's the main menu. Those are the parameters that we're going to set from the main menu. The other menu is for setting the J1 and J2 parameters, and let's take a look at that real quick. All right, the other menu is what I call the relay menu, and Again, from the set button on the front of the display, you hold set, it'll go to the 4 zeros. We're going to select 0001, and that'll take us to the relay menu. In the relay menu, we're going to have J1 settings and J2 settings. So those are the upper and lower settings for J1. J2 then takes us into this, and from this J1 or J2, from this point, what you're selecting is either volts, amps, or amp hours. That's something I omitted when we were talking about features. One of the nice things about this unit is that we are these two relays, but it's also that these relays can be activated based on either volts, amps, or amp hours. We only use it for volts. The other option would be you could use it for amp hours, would be probably the other most common way to use these relays. So in this, when we go to J1, that's what we're selecting. We're selecting what's J1 going to be controlling, what's it going to be monitoring, amps, volts, or amp hours. And same with J2. And you can have one doing volts and the other doing amp hours. I mean, they don't have to be the same. So again, you set your upper and lower limits for J2 if you're using J2. And then to exit the menu, you select end. Like I said, we typically use J1 for our charger shutoff, and we use J2 for our low voltage protection on our pack. So let's go to the vehicle and take a look at one that's connected. All right, here we are inside the vehicle, and we're going to take a look at the JLD404. And so right now we're displaying amps. No amps, we're not charging, we're not running down the road or anything, so we're at 0. We're at 150.7 volts. The thing was charging earlier, and so it is slowly dropping down to its at-rest voltage after the charger shut off at 154 volts. Amp hours. We can see that it didn't go all the way to 0. We're showing a negative 0.148 amp hours. So didn't put quite as much in as we measured taking out. And I said there's several reasons for that kind of discrepancy. But all we have to do is press either the up or down arrows. I'm going to press the down arrow. I'm going to press and hold it. That takes us to 0. Next is our clock. And so the clock is 0 volts. So anyway, you can see the positive and negative signs here, plus and minus. None of those lights are on. J1 and J2, nothing's lit. Nothing's on currently. So what we have it is that J1 is set to the normally open contacts, so that if we had a 12 volt failure, the charger would shut down. If there's a 12 volt failure, this no longer has 12 volts, that relay will open up and shut down. But we have it set so that when it drops down to 150 volts, the charger can then be back into operation. Right now, if I plug the charger in, it's not going to do anything because we're exceeding 150 volts. So what I'm going to do is I'm going to turn on the key. We'll put a little bit of draw on things. We'll draw it down 0.7 of a volt, and we'll see the J1 light come on, which would mean that the charger is ready to be used. At this point, anything above that, it's not worth plugging in and charging. So even at 150, but we just want it to be at a point where anytime it wanted to be charged, it would be able to charge, but yet we have this shut off point. So here we go. Ignition on. We're starting to draw out of the pack now. My cooling blowers are on and so forth. we're drawing 9/10 of an amp, so that's going to draw us down here. Make sure we're in neutral. I'll give it a little throttle. We'll pull it down a little faster that way. Here we go. Remember, as soon as it hits 150, J1 should kick in. There we have it. So now we're at the point where we can plug the vehicle in and it will charge. So let's take a look at the programming features on this. So I press set and it flashes. Now I use this arrow to move over, the side arrow. And I'm going to use the up and down to put in the code. I'm going to use the up to put in the code 36. Use the side arrow over again. And hit set to enter that. So there we have what we had on the board that we were talking about. So this is the amps, the current N, and so we can hit enter again and it's going to show us that value, and so that's the 75 microvolts that we've chosen. And we're going to go down. We'll check the next one on the menu. Oops, guess we want to go up. And this is the amps, the 0 offset. We'll show you that. We'll hit set. And so we've got it set right there at 0. And this is going to be the full scale value of amps, the most that we'll have on our display. And we've got it set at 750. Next, this is amp dot. That's the decimal point, where we want our decimal point set. So we're going to have it just show tenths. And this is our voltage. So we're on that scale on the back that we saw. This is basically setting, what scale we're reading. Just like it was on the amps, the 700 millivolts, that's what terminal we're set on. Well, we got it on 500 volt terminal. This is the volts. Full scale display on the volts. I'm sorry, this is the lower. It'd be so got that set at 0. Now this is the upper. This will be the full scale reading. So again, it's the 500. And the decimal point on the volts, we're just going with 1. Again, we don't need it out 3 places. And this is the filter that I was talking to you about. We've got it set on 1. I think you have a choice between, or is it 1 and 4? 2, 3, 0. 0, 1, 2, or 3. Use either 0 or 1. We had it on 1. I don't know why. We'll just leave it where we had it. Oops. And then next is N. That will take us out of that menu. We're back to our main display. So that's the main programming features. Again, there would be, slight variations in these settings based on differences in shunts that you would use, difference in the voltages of the pack that you will use. But this is probably the most common setup as far as the maximums, minimums, decimal point, all that. You can see how easy it is to set all that up. So next, let's move on to setting up our relays, J1 and J2. So like I said, to go back to our menu, we're going to hit Set. We're going to move this over to 0001. Boom, J1. So we're going to hit Set again, and that will tell us. So J1, that's volts, amp hours, amps. So those are our selections, and we want it on volts. Next choice is the upper activation level for J1. So if we hit that, we get to choose our value. And so because we're using the normally open side of the relay, this is where that relay is going to close. The relay closes at 150 volts, as we showed earlier. And we'll plug it in and watch it go the other way, and you see it shut off. So that's where we want it. Again, if you wanted to select something different, you just move these up and down, and you move over to the different places. Okay? Next is the low level, and so this will be where the thing shuts off. And so we'll hit that, and that's our 154 volts. That's when that relay is going to open back up. So the relay opens up, voltage drops back down to 150 or less, the relay closes again, and so that's how that works. If we were using the other terminals, things would be reversed. Next, it takes us to J2. You hit J2. Again, you have the choice between the different settings. We're not using J2 on this vehicle. Now, next one would be the high setting on J2. This is just what the meter came set at. We haven't messed with this because we're not using J2 on this particular vehicle, but that's what it's set at. And then the lower setting. And so when they're the same, did you notice this? 510, let's go back. 520. Well, they're not the same, but we're never going to get to those voltages, so it's never going to come on. But you can set them at the same, and that basically disables that relay. Something I didn't mention earlier, I better mention now, and that is that the relay, they're just 3 amp relays. And so to exit the menu, and so the relays just for operational purposes. It would then any heavier loads you would then use, if you're not just using it for a low current switch, you would have to have it switch a relay that would handle higher current demands. So remember that, it's only 3 amps. And so I'm going to plug it back in, and it'll charge us up real quick, and then we'll be able to watch this J1 go off again. Okay, I plugged it in. It's charging. Let's go over to the amp scale. Charger's still winding up here. plugged into 110 volts. It's not going to go up to the full. Normally it charges about an amp more than that, but since it's so high, it's not going to do that. It's only going to 7.8 because the pack's basically charged. And it's going to drop. Take a look at our voltage here. You can see it climbing. Our amp hours. We'll watch the volts here. As soon as it hits 154, it will shut off, and you'll see J1 go out. That relay is latched right now. Boom, unlatched. Charger is taken out of this circuit. You see the charger is shut down, so we're going to see the voltage slowly drop. Hope you noticed when it was charging, the plus indicator was on. So now we'll put a load on here. But first, what I'm going to do is go over here and I'll zero out my amp hours. So I'm just going to press and hold this again. Normally when it's close like that, I don't even bother resetting it. Okay. Turn our ignition back on. My DC-to-DC converter is coming on now instead of just pulling everything off of the 12-volt battery. Now we've got a load on the traction pack. Give a little bit of throttle. Speed things up here. Here she goes. Well, a little more. Boom. J1's back on. We could plug it back in if we wanted to. But that's how that works. And again, like I said, J2, I mean, you could have them operate whatever you want them to operate. This is just how it works. Suggestion of possible uses. But that's why this is a nice little instrument. And so in my normal driving, I have it on that display right there so I can watch my consumption. It's kind of an efficiency gauge, kind of like a vacuum gauge is on internal combustion. And then the volts, that's just my check. I know exactly where this should be. Based on the particular pack. And so this is a 100 ampere hour pack, so I've got 80 amp hours that's usable. Just a little playing around here, we used 0.079, trying to draw it back down to 150 volts. But I can use up to 80 amp hours on this pack. If we had a 180 ampere hour pack, we'd have 144 amp hours that were usable. And so, very handy little gauge. We've got the relays that act as redundancy systems. Like I said, we're using it to protect our pack from overcharging. We're using it to protect packs from over discharge. You can use them for different things. You could have it where it's doing it on amp hours. We do it on voltage strictly. That way if someone doesn't reset the pack and you have some error built in, the thing's still going to operate based on the pack voltage and not the meter's perceived amp hours at any particular time. So anyway, I hope you find this of value. This is just kind of an overview of the JLD404 Intelligent Amp Hour Meter. And if you have any questions, feel free to email us at info@evforyounow.com. And if you enjoy our videos, we ask that you please subscribe to our YouTube channel. And as always, thank you for watching.
Hello.
I'm Richard with EV4U Custom Conversions. You want to learn more? You want to learn about all the components in greater detail? You want to actually install the components and wire conversion? Test it and drive it? Well, you can. By attending one of EV4U's 3-day hands-on conversion workshops. You will get a chance to learn, discuss, ask questions about all the components used in a conversion. Wiring techniques, hardware used, safety, how it all goes together, and much more. But we don't just talk about it. We go into the shop and install the components in a vehicle, wire it up, and test it. After testing in the shop, we test it on our test track and in the industrial park where we're located. One of the vehicles we'll be using in 2014 is our sand rail. It's a blast. So come join us for 3 days of education and fun. Meet people from all over in a beautiful setting while learning how to convert a vehicle from gas to electric. EV4U provides lunch each day at great local restaurants. After hours, you can visit many of the local attractions, like Shasta Lake, the largest lake in California, Shasta Dam, the second largest concrete dam in the United States, Shasta Caverns. You can take a dinner cruise on Shasta Lake, take a walk on the Sundial Bridge, visit Mount Shasta. There's night skiing available during the winter. Visit Burney Falls National Recreation Area, or go kayaking at Whiskeytown Lake. You can check out the source of the Sacramento River. Sacramento River is the largest river in the state of California, and you can see where it bubbles out of the ground. We've got world-class fishing, hiking, and biking, all within minutes of EV4U's shop. So we'll hope you'll join us. So visit www.ev4unow.com and register today. The class sizes are limited, so don't delay.